Chapter 12.2, Measures of Central Tendency. In statistics, values that represent average or typical are known as measures of central tendency because they're generally located towards the center of the distribution. 4 such measures are discussed in this section: the mean, the median, the mode, and the mid-range. Each measure of central tendency is calculated in a different way, so it's better to use a specific term, mean, median, mode, or mid-range, than to use the generic descriptive term of average. By far, the most commonly used measure of central tendency is the mean. The mean is obtained by adding all the data items and then dividing that sum by the number of items. The Greek letter sigma, which looks like this, is used to indicate the sum of the data items. So we get this formula where we use this symbol, which means the sum of x, to represent the sum of all the data items, and n represents the number of data items. So your formula for the mean looks like this. For example, if we had, let's take some data items, and we wanted to find their mean, we would add them all up. So the mean would be 1 plus 3 plus 7 plus 5 divided by 1, 2, 3, 4. So 10, 15, 16 divided by 4, or 4. The mean of a sample is symbolized by this symbol, which is red X bar, while the mean of an entire population is symbolized by this symbol, which is the lowercase Greek letter mu. Unless otherwise indicated, the data sets throughout this chapter represent samples, so we'll be using X bar to indicate the mean. The median splits the data items down the middle, just like the median strip in the road. To find the median of a group of data items, first of all, you arrange the data items in order from smallest to largest. So if I'm going to find the median of these these 4 data items up here, my first step is to put them in order from smallest to largest. If the number of data items is odd, it's simply the data item in the middle. But if the number of data items is even, like we have right here, 4 data items, then the median is the mean of the 2 middle data items. So I can either do halfway between these numbers. If my numbers are easy like this, 3 and 5, I know what's halfway between 3 and 5. It's 4. But if I had numbers maybe like 98 and 103, or let's make 137, and I'm wondering what's halfway between 98 and 137, I can find their mean. In other words, add the 2 numbers together and divide by 2, since there are 2 numbers. And the median for this data set is 4. And that is just a fluke that the mean and the median turned out to be the same number, right? Just a fluke. They are not typically the same number. Okay, let's say that this was my list of data items, so 1, 3, 5, 7, 10. Now that I have an odd number of items, it's simply the value in the middle. So my median for this set of data would be 5. If a relatively long list of data items is arranged in order, it may be difficult to identify the item or items in the middle. In cases like this, the median can be found by determining its position in the list of items by this formula. So for example, now it's easy to look at these and see what is the item in the middle, but let's say that it's a very long list of numbers and I can't really determine what's in the middle. Then I can find that middle position by counting them 1, 2, 3, 4, 5. So that's what n is. So 5 plus 1 over 2 equals 6 over 2, 3. Now don't forget, that's the position of the median, not the actual value of the median. So now I come back up here and I say, well, the third number, 1, 2, 3, that third number is my median. Likewise, when we had 4 data items, and let's say we had, 40 data items, and I wasn't sure where the middle were, I could plug into this formula. So 4 plus 1 over 2 is 5 over 2, or 2.5. Notice it tells me it's halfway in between the second and third data item. So here's the second and third data item. I need to find halfway in between there. Okay, so the mean and the median. Let's look at an example. The net worth in millions of 2010 dollars for 10 U.S. presidents from Kennedy through Obama is listed in this list. So Kennedy was worth $1,000 million. In other words, $1 billion, right? Johnson, 98 million. Nixon, 15 million. Ford, 7 million. Carter, 7 million. Reagan, 13 million. Bush, 23 million. Clinton, 38 million. The second Bush, 20 million. Obama, 5 million. Okay, so let's find the mean and the median for this set of data. So first of all, I'm going to find the mean. I add them all together. So we'll have 1,000 plus 98 plus 15 plus 7 plus 7 plus 13 plus 23 plus 38 plus 20 plus 5, and divide by how many there are. And there are 2, 4, 6, 8, 10. Remember, if you're doing this on your calculator, you want to have parentheses around those that you're adding. So I am going to pull out my calculator and add 1,000 plus 98 plus 15 plus 7 plus 7 plus 13 plus 23 plus 38 plus 20 plus 5, and I get 1,226. So when we divide that by 10, we get 122.6. So the mean net worth of these 10 presidents is $122.6 million. Let's find the median. To find the median, I've got to put this data in order. So 5, okay, I might want to keep up with it just to make sure. 7, 7, 13, 15, 20, 23, 38, 98, and 1,000. Now, there's not too many data items here. I can probably count from both ends, and kind of meet in the middle. However, just for practice, let's use our formula. I've already counted them. I know there's 10. So 10 plus 1, 11 over 2 is 5.5. I need to get halfway between the 5th and 6th data items. 1, 2, 3, 4, 5, and 6. Halfway between 15 and 20. Well, I know that's 17.5, but if we didn't know that, all we have to do is come over to the side and add 15 plus 20 divided by 2, right? Take their mean, 35 divided by 2. So the median for this set of data is $17.5 million. Which one looks like a closer representation of the average? Statisticians generally use the median rather than the mean when reporting income. Because when one or more data items are much greater than the other items, these extreme values can greatly influence the mean. In cases like this, the median is often more representative of the data. Okay, look up here. Let me erase where I've got these marked out for us so that we can look at these values. 122 million. There was only one president that was over 100 million. Every other, so 9 out of 10 presidents didn't even get close to 122 million. That's not very representative. Okay, 17.5 million. Oh yeah, I've got, a 13 million, 15 million, a 20, a 23 million, a little more representative of the center of the data. In the United States, the wealthiest 20% of the population earn about 50% of the total income. The relatively few people with very high annual incomes tend to pull the mean income to a value considerably greater than the median income. Reporting mean incomes would inflate the numbers, making them non-representative of the millions of workers. Imagine if you worked for Microsoft and you were doing a report on the average income for Microsoft workers. Imagine what that's going to do if you throw in Bill Gates' income, right? It's not going to be reflective of the thousands of other workers in that company. So keep that in mind also. It's really important to know which average, if someone has just used the word average, which average are you talking about, right? I could use this number or this number and legitimately call them average depending on what I'm wanting to support, which view I'm wanting to support. So just something else to be careful of when making informed decisions, right? Educated decisions. Okay, the mode is the data value that occurs most often in a data set. If more than one data value has the highest frequency, then each of the data values is a mode. If there is no data value that occurs most often, then the data set has no mode. The mid-range is found by adding the lowest and highest data values and simply dividing the sum by 2. In other words, it's an average of the lowest and highest. It's sometimes used for just an easy way to get an estimate for the mean. The mid-range, probably the most useless of the three, though. Let's go see if I can go back and find the mode and the mid-range of the data up here. Okay, the mode would be, here, let's put it here where we've got it in a list, 7, right? So since there are 2 data items that are exactly the same, the mode would be 7. Okay, and the mid-range would be 1,000 plus 5 divided by 2. So 1005 divided by 2, which would be, what would that be? 502.5. Notice, not really very representative. Okay, 502 million, but it is an acceptable average. Again, it's very important to know which average people are using. On a mode, it is possible to have more than one mode. Okay, and we'll look at that in just a moment on some of our examples. And if you have two modes, let's go back. If you have two modes, you can call that bimodal, right? Two modes. Depending on the book you're following, some allow to have 3 modes or more, but typically if it has 3 or more modes, we're just going to say there's not a mode. You know, if my data set looked like this, 5, 5, 7, 7, 3, 3, right? There is not an item that appears more often than the others, basically. Right? Yes, 5 appears more than 1, and 7 does, and 3 1, but typically there's no mode. If it looked like this, then I'd say, oh, the mode is 3. 3 occurs more often than the others. And we'll go up to 2 modes here that we're going to allow. So, for this group of data items, find the mean, median, mode, and mid-range. For the mean, right, which we can represent with X bar, the mean, I'm going to add them up. 1 plus 3 plus 5 plus 10 plus 8 plus 5 plus 6 plus 8, and divide by 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. And I'm just going to plug that in my calculator. So 19 plus 13 plus 14 is 46 divided by 8, which is 5.75 for the mean. Okay, to find the median, I need to rewrite those data pieces in order. So 1, 3, 5, 5, 6, 8, 8, 10. Double check that I've got them all. There should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and since there's 8 of them, the median will be between the 4th and 5th number. So 1, 2, 3, 4th and 5th. Halfway in between 5 and 6 is 5.5. That's the median. The mode, I simply notice that I have 2 5s and 2 8s. So the modes, this time I have 2 modes. This set of data we would say is bimodal, or 5 and 8. And the mid-range is found by adding the smallest and largest and divide by 2. So 11 over 2, or 5.5. Notice that the mean, the median, and the mid-range do not necessarily have to be an actual data item, but the mode must be a data item. Let's look at finding the mean, median, mode, and mid-range for the data items in the given frequency distribution table. All right, So first of all, let's just kind of recall what this means. Here's a list of scores. So if I were going to take this out of my table, again, as just a long list of data like we have up here, because it says the frequency is 2, that means I have a 1 and a 1 for my data items. And then I have 4 2s and 5 3s, etc. Right? So that's what my data looks like. Well, remember, if I'm finding the mean, I would say 1 plus 1 plus 2 plus 2 plus 2 plus 2. Or I could simply say, oh, that means I have 2 1s. So one way I could do this is just say, oh, I have 2 1s, right? 1 plus 1. Plus there are 4 2s. So instead of having to say 2 plus 2 plus 2 plus 2, I can say 4 times 2, right? And instead of having to say 3 plus 3 plus 3 plus 3 plus 3, I can say 5 times 3. And since there are 7 4s, instead of adding that together, it's the same thing as multiplying 7 times 4. There are 6 5s and 4 6s and 3 7s. And I'm going to divide by the total. Hopefully would have a total down here as our bottom row of our frequency distribution. A lot of times this text does not do that. So let's total them up. Just add them up. Here's 10, 29, 31. So I'm going to divide by 31. I just added 3 plus 4 plus 6 plus 7, right? Added the frequency to get the number of data items. And I'm going to plug that in my calculator. 2 plus 8 plus 15 plus 28 plus 30 plus 24 plus 21 and divide by 31 to get 4.129, 0, dot, 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 let's round to 3 decimal places, for the mean. Now, to find the median, I want to find that data item or items in the middle. We know there are 31 data items, so plugging into my formula to get me the position of the median, I find out that it's in the 16th position. Meaning, right, if I were to line them up like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I would just count until I got to the 16th. But think about this. That means, oh, here's 2 and 4. There's 6 and 5. There's 11 by the time I get to the end of the 3s, which I just counted up here and found out that's true. So 11, if I add 7 to 11, I get 18. So 4 is the 16th one. Not only the 16th, it's the 12th, 13th, 14th, 15th, 16th, 17th, and 18th position. But I don't care about that. The 16th number in my list when they're in order is a 4. So 4 is my median. Okay, if I'm going to find the mode, it's simply the number that occurs most often. And look at this. The frequency is telling us how often these numbers occur. There are 2 1s, 4 2s, 5 7s, 5 3s. There are 7 4s. That's the greatest frequency, or the mode is 4, because there are more 4s than anything else. And then finally, the mid-range is a very simplistic version of the mean, where I take the smallest score plus the largest score and divide it by 2. 8 divided by 2 is 4. Notice your mean, median, mode, and mid-range. Now my mean wasn't on this one, but it's possible that they're all the same number. But they don't have to be, right? And remember, your mean, median, and mid-range doesn't even have to be one of your data items. Okay, let's try it again, except this time, what if our data is arranged in a histogram? We've seen this histogram before. It's the boys' ages of maximum yearly growth. Here's the number of boys, right? So in other words, our frequency. So if I'm trying to find the mean, this tells me the same thing that a frequency distribution table does. It tells me there was one boy who had his maximum growth at 10 years of age. 2 happened at 11. 5 boys had it happen when they were 12. So I know there is 1 10 plus 2 11s plus 5 12s plus 7 13s plus 9 14s plus 6 15s plus 3 16s plus 1 17 plus 1 18 divided by, now I've got to know how many data items there are. 1 plus 2 is 3, plus 5 is 8, plus 7 is 15, plus 9 is 24, plus 15 is 39. Let's start this over. Not plus 15, plus 6. Let's start this over. Okay, here's my frequency. 1 plus 2 is 3. Okay, plus 5 is 8 data items. Plus 7 more is 12 data items. 5 plus 7 is 12. Plus 9 is 21 data items. Plus 6 is 27 data items. Plus 3 is 30, 31, 32. So 32 boys. And I'm just going to, again, put that in my calculator. 10 plus 22 plus 60 plus 7 times 13 plus 9 times 14 plus 6 times 15 plus 3 times 16 plus 17 plus 18, all divided by 32 to get 15.0625. So let's say 15. Okay, let's find the median. We know there were 32 data items. So our position of the median will be in the halfway between the 16th and 17th data item. So here's 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, 11, 12, 13, 14, 15. 16 and 17 data items are both 9. So halfway between 9 and 9 is 9. Okay. What if we're finding the mode? Well, that's just our tallest bar, right? Since our bars represent our frequency. So there were 9 boys at 14. All right. By the way, I hope you caught that over there. Just checking to see if you guys were paying attention. Right? Yep. Just checking to see if you guys were paying attention. I was up here at my position, but my data value, right, in the 16th position was 14. Right? So, sorry about that. Okay, so let's do this one over. All right, I know it's got to be between the 16th and 17th position. So this is my first data value. Here's my second and third. Here's my 4th, 5th, 6th, 7th, and 8th data value is 12. Okay, 8 and 7 are 15. So my 13th through 15th data values are 13. And then here are 9 more data values of 14. So the 16th data value is 14 and the 17th data value is 14. Okay, and then the mode, of course, is the highest bar. Now it goes to 9, but that's just saying 9 boys were 14, right? And then finally the mid-range, which we will take the smallest data value and add to the biggest data value and divide by 2 to find their average. So 28 divided by 2 is 14. Again, just a fluke that on the last two problems, the median, mode, and mid-range were the same number. Right? They could all be the same number. They could all be different. Okay, that wraps up Chapter 12.2, Measures of Central Tendency. I'll see you next time.